Hi everyone, this is Mr. Cervone. Welcome to my math channel. For today's do now, show that the triangle with vertices h 2, 8, j 0, 3, and k 7, 6 is isosceles. So let's first graph it and look at it. So if you plot the points h, j, and k and then connect them with segments, it looks like here as shown in the figure, okay? So in order to determine if it's isosceles, you need to somehow look at the lengths of these segments and compare, for example, the length of segment JH, segment KH, and segment JK. So how do we do this? Well, there's a concept in coordinate geometry that is called the distance formula, okay? So let me introduce the distance formula first, and then we can go back to solve this problem. So let's say you have 2 points in the coordinate grid on the x and y axis. Point A, I will call it x1, y1, and point B, let's call it x2, y2. How do we find the distance between these 2 points in terms of x1, x2, y1, and y2? Well, the best thing to do here is to first draw a vertical and a horizontal line such that you end up with a triangle ABC, and then we can use Pythagorean theorem. So let me demonstrate what I mean. Okay, so here's our triangle. So the first thing we want to do here is to first determine what is this point over here, and let me first call it point C, okay? So what is the x-coordinate of this point? So the x-coordinate is the same as this one, x2, because they share the same x-coordinate over here. So this is actually x2. Now what about the y-coordinate? Well, the y-coordinate is the same as this one because they share the same y value at y1. Okay, so notice that when we draw these lines here, we make sure that segment AC is parallel to the x-axis, and segment BC is also parallel to the y-axis here, okay? We also know that the x and y-axis, by definition, are perpendicular. So therefore, angle ACB has to be perpendicular as well. And now we can apply the Pythagorean theorem. Namely, AB squared is equal to AC squared plus BC squared, okay? So if we do the math, we have AB is equal to the square root of AC squared plus BC squared, okay? And that is really the basics or the foundation behind the distance formula. All we need to do is find AC squared and BC squared, okay? So let's write this here. So here we have AC is equal to, well, what is the distance between A and C? Okay, so the y values are the same, but the x values change. So you subtract x1 from x2, like this, okay? So that is the distance between A and C. Therefore, AC squared must be equal to x2 minus x1 squared. In a similar manner, the distance between B and C is equal to the difference in y values because the x values are the same. So we just write y2 minus y1. Therefore, BC squared has to be equal to the difference between the y values squared, okay? So now that we have this, we can now finally substitute it into the Pythagorean theorem. So we have AB equal to the square root of AC squared, which is x2 minus x1 squared. And then we have plus y2 minus y1 squared. And that is exactly the distance formula, okay? So again, the distance formula is defined as, well, in this case, we're calling it D, the distance between 2 points on a coordinate system, is the square root of the difference in x squared plus the difference in y squared. So let's go back to the do now and solve the problem and see if it's an isosceles triangle or not, or show that it's an isosceles triangle. So here, point H is 2, 8, J is 0, 3, and K is 7, 6. So the first thing we want to do is find the distances between all these points. Okay, so let's say we get started with the distance from H to J. Okay, so you write it like this, Hj equal to the square root of, and now we're going to look at the distances in X, okay? Maybe what we can do is label these points here so it's easier to see them, okay? So we have K is 7, 6, and then we have J, which is 0, 3. Okay, so the distance from H to J here. So first we do the distance in X, which is 2 minus 0, and then we square it, plus, and then we look at the distances in Y, okay? 8 minus 3, and then square it. And then we'll take the square root of all of this, and we should get a value of square root of 29, okay? Because here we have 4, okay? So this is going to be 4, and this is going to be 25. 25 plus 4 is 29. Okay, so we got the square root of 29. Let's find the value or the distance between J and K over here. That is equal to the square root of the X values, the difference of the X values, okay? So which is, let's say 0 minus 7, and then we square it, plus, and then 3 minus 6, right? And then we square it. Notice that even though you end up with negative numbers here, when you square a negative number, you end up with a positive value anyways. So the answer is going to be positive, okay? So here we have square root of 58, okay? And now let's find the distance between H and K. Okay, so again, that is the square root of the difference in X, which is 7 minus 2 squared, plus, and then we have 6 minus 8. And then we'll square it, okay? Okay, so if we take the square root of all of this, we end up with square root of 29. And there you go, we actually showed it that this is a isosceles triangle because Hj is square root of 29 and Hk is also square root of 29. Therefore, those two segments are congruent and they have the same length, and therefore it's an isosceles triangle. Okay, so this was it for today's lesson. Please make sure to remember the distance formula and finish your homework assignment that will be due on Friday. You can find the homework assignment either in Schoology or Puba Path, okay? So again, thanks for watching and have a great day.